Hello everybody, welcome to my quick guide to Python. This is not meant to be like an in-depth guide if you've never done Python before, but it's meant to be a little bit of a refresher um, and as a way to teach you syntax if you already know another language. So I am joined here by a bunch of my peers at the TU Delft from the TU Delft freshman year, and we have to use Python for a few classes. So that's why I'm doing this. They already know Java. I'm going to assume you know Java or another language too, so I won't go into like the exact details of what if it is an if statement and stuff, but it should all be pretty straightforward. I'm gonna go over these things. So like first a little hello world program, then about control flow, lists, loops, functions, strings, dictionaries, and modules. I ripped all of this straight from a code teaching website. I just logged into the most generic code teaching website and picked all their topics. I'm like, okay, I'm gonna do that. So first of all, let's get started by how to find Python. Then we go to python.org/downloads. That was a ping on my PC, by the way, so you guys don't have to worry your thing. That's going to happen more often. Then you can click download Python, and it will give you a Python installer. I already have it installed, so I'm just going to launch it. And I'm going to launch the Python IDLE. Now, IDLE stands for, I have no clue. Let me check. Integrated Development and Learning Environment. And it's just something that comes with Python that's really nice. So you can have like, it's basically like a JavaScript console, but a little nicer. You can also go here to File, New File, and here you can actually write programs which you can save and then run later. And yeah, this is basically where you would write the Python files. So let's get started with a little hello world program. So it doesn't have to be hard. So it's print hello world like this. There are a few things you can notice already. There's no semicolon. Python does not require semicolons. And second of all, printing stuff instead of system out print line is just print. Super neat. Yeah. At any point, by the way, especially from the people I'm here with, if you have any questions whatsoever, shout, ask. I am here to help you guys. I already know all this stuff, so if you have any questions, if I'm going too fast, or anything like that, just let me know. Okay. So we have our first hello world program. Let me actually see if I can make this a little bit bigger, if that's possible. Can I zoom in here? Can you guys see this properly? Maybe this one? Oh.
Yeah, it looks fine.
We can see it, but it might be small if you don't have adequate resolution.
Apply. That's a little big.
20 should be.
Like 16.
Yeah, that's good.
Okay. So let's start out with variables. So in Java you would say integer I is equal to 3. In Python we just say I is 3. Python is I think it's called dynamic type language, which means there is no static typing. You don't have to say, okay, this is an integer, this is a string. Hell, if we look at I, it is now the number 3. And now I can set I equal to the letter X, or a string containing the letter X. You can do whatever you want with your variables. There is no limit. I can make I a list. I is now a list containing the numbers 1, 2, and 3. So you don't have to statically type your variables. You don't have to worry about the typing of them. If you want, you can use, I think it's either type I. Yeah, type I, and that will give you the type of the variable you're interacting with. But yeah, all in all, it's not statically typed. You can do whatever you want with it. Alright, if that's clear so far, then we are going to move on to, let me say, check. Let's have a look at control flow. So I'm going to make a variable, let's call that number is equal to 5. If number is bigger than 4, let's print big. I don't know, I'm just doing random stuff. And as you can see, it printed here big. However, this introduces a really interesting thing in Python. So if we put our code here, you see that Python does not use curly braces. Rather, it uses indentation. So I'm going to save this file somewhere. Let's call it messing around. So this file compiled. However, this file doesn't. So Python forces you to use indentation instead of bracket, which in my opinion is super nice because you have to have proper indentation in your files, which makes everything you write a lot more readable. However, there is also plenty of people who I know will disagree with me and say it's really annoying, especially when you're transferring stuff from one text editor to another, because there might be differences. One uses spaces, one uses tabs, whatever. For our thing, we can use either, I think, 4 spaces or 1 tab. So that doesn't matter too much. Let's see. Let me define another variable. So in Java, you had these things for and, or, and not. Python is a lot more descriptive. I've heard some people say that Python actually almost reads like it's pseudocode. So here you see if number is bigger than 4 and number 2 is less than 10. And then you can see that this works. And we can also have and not number is bigger than 4. Well, then it won't print it because, you know, this would be the same. Let me actually make this a little smaller. So this would be the same in Java, saying, oh, if number is bigger than 4 and not number 2 is less than 10. So this is what it would be in Java, this is what it is in Python. We also have elifs. So we have if number is bigger than 4 and not number is less than 10. Then we have elif number is bigger than 4 and number 2 is less than 10. And then we have else's none of the conditions apply. So we can see number 4 is bigger than 4, or number is bigger than 4 and number 2 is less than 10, so it will get here. So this is how you do an if, elif, else in Python. Alright, that's the biggest part of control flow. Now let's have a look at lists. Is everything clear so far, by the way?
Yeah.
Okay, cool. I will also look at the general VC channel if somebody who doesn't have a mic, they can ask questions there. So now let's have a look at lists. So in Java, to create an array of numbers, you'd have to do int array equals new int 1, 2, 3. In Python it's a little bit easier. You can just say int array is equal to 1, 2, 3. So here you can just see we use square brackets for lists, and we can just list stuff in there. And it can also be different. It doesn't matter what is in there. So we can have integers, strings, another list, floating point numbers, longs. And that's also a fun thing of Python. Python does not really have a limitation on how big your numbers are. So if I say int list, it's called int array actually, and then I take the third index, because remember 0, 1, 2, 3, or actually, yeah, okay, sure. This will be 0.1, so that will be this one. But when I take the fourth index, it will be this number. And if I, for example, square this, it'll be this number. And if I cube this, it will be this number. And if I do it to the power itself, my PC will probably lag a lot. However, as you can see, it doesn't give any error because Python numbers can be as big as your own memory allows. I am going to close this window because now it's going to freeze. That's a really big number. Okay, let's see. So we have lists. Now let's work with loops. So let me get rid of this stuff. Okay, loops are a little bit quirky in Python as well. Loops actually specifically iterate over a list. So if I have the list, let's call it string list is equal to A, B, C, and I want to print all of these items individually, I can do for I in string list print I. And this would be equal a bit to, let me actually copy this over to here. This would be equal to, for example, in Java. Oh, again, I'm pulling a lot of similarities between Java and Python here, but that's because people here have done Java. That would equal to for string I in string list. So basically, all lists in Python use this. However, if you want to just have a normal, quote unquote, normal for loop from Java, how you're going to implement it in Python if you only can iterate through lists? For that, we use the range function. So if I say range 0 to 10, actually that doesn't work there, so yeah, what this does is this creates a list that counts from 0 to 10, with 0 included and 10 excluded. So if I do for I in range 0 to 10, print I, what this is going to do is this is going to create a list, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to iterate through that. So this would be the same. Here you can see how that works. This would be the same as saying for int I is 0, I less than 10, I plus plus. Oh, mixing syntax here. This should be a thing as well because because those examples are in Java. But yeah, this is how you do for loops with numbers. I can also do the example of squaring all the numbers. This is how you square something. Apart from that, I think most of the operations in Python are relatively straightforward. So we can have a number times another number plus another number minus another number divided by another number. And because we and so it of course uses the order of operations. So this becomes 3. This becomes 2. So then it's 3 plus 2 minus 2. And because we use a division here, it actually turns everything into a float. And if you don't want to do that, you can use a double slash, which is flooring into the integer division, which is basically just divide something and then just chop off whatever part is left behind the comma. Oh yeah, I almost forgot. We also have while loops. So I can say count equals 100, total equals 0, while count is bigger than 0, total equals total plus count. So what this is going to do is this is going to take the sum of all the numbers from 0 up to and including 100. Or well, actually, it's going to start at 100 and then count is equal to count minus 1. It's going to start at 100 and then go down until it's at 1. And of course, it doesn't print anything because it didn't tell it to, but now I can look at total and it should be 50-50. So it's just like while loops in Java as well. So there's nothing really too new here. It's just a syntax. And again, we can see that it doesn't use curly brackets. It's just colons. I think that should be it on loops. Oh, we can look at functions. Nice. So let me actually post all of this in the general VC channel as I go, so that you guys can look back at it if you want to. If you're watching this video back later, unfortunately, if you're not a TUDL student, you won't have access to that channel, but too bad for you. So let's see, functions. We can define a function called greet me that just prints out hello. And these work just like you would expect them to. So I can here call greet me, and it will print hello. I can say for I in range 0, 10, greet me, and it will print hello 10 times. From 0 to 9, inclusive. However, I can also make it more personalized. So when I say def greet person, that takes an input parameter called name. And again, because Python is dynamically typed, you do not have to pass a type to this name. I think you can, however, I don't think I've used it much, so I don't know the exact syntax. I think it might be something like this, but I'm not sure. And then we can print hello, comma, and then we append the name to the print statement. So I can say greet person Jurre. Hello Jurre. And I can say greet person Con. Hello Con.
Oh, hey, that's me.
Yeah, hello. So this will work with anything, and this works just the same as if the value here was that. So again, there's no type restrictions here. So if I pass a number in here, it's gonna try to append a number to a string, which won't work. However, there will not be a compilation time error, or well, I think it's an interpreted language, so there's not much compilation, but it's gonna complain when actually trying to execute this command. So everything before here will get executed. Again, to avoid this, we could just cast it to a string, which you do by doing str. You have the same with int, float, list, and all the other stuff like that. All right, we can also make a function, def fib, which takes a number, and then we say if number is equal to 1, return 1, else return fib number minus 1 plus fib number minus 2. And I should also have the base case of elif numbers equal to 0. Return. What's the Fibonacci of? Or actually,
You can't just do greater than or equal to 1. Less than or equal to 1, I mean, because Fibonacci of 0 is also 1.
okay. Let's see if this works. Again, I haven't done ADS in a while, so I might fuck this up. But if I want fib of 10, 89. And then the next one should be 89 plus 55. That's 144, I think. There we go. So if recursive functions just work like that, yeah, like you would expect them to. Yeah. I think that's all I have to say about functions. All right, let's talk a bit more about strings. So imagine we have a string. I'm gonna put this in the thing as well, by the way. Imagine we have a string, and the string is it's called my string is equal to Jurre. There's a bunch of stuff we can do with this. So when I say my string, it now contains the word Jurre. I can say what's the length of my string with the len function. Jurre has 5 letters. I can index it. So this is kind of like you would index a list. You can directly do that in Python using just the same notation as you would with a list, which is really nice. So taking the first letter of a string is just opening bracket 0 closing bracket. We can also do something called list splicing, or in this case it will be string splicing, I guess, which means take all the letters after the 0th one, including that one. So this will be everything after the first one, everything after the second one, etc. Or I can say start at nothing, but do everything until the last one. And I can even say start at the first one, or I guess the second one, since we're counting from 0, and stop at the second to last one, and this will be So that's a neat little trick for string indexing. Usually, I guess in Java you would use either a built-in function or a loop for that, but in Python we just have this neat little slicing syntax. Let's see, what else is there to talk about strings? Well,
In Java, you could also just use substring, couldn't you?
yeah. I'm not sure if substring also allows you
Yes,
to
you
do.
can substring from you could just do mystring.substring 1 comma string dot length minus 1.
That's pretty. Yeah, okay, that's fair. I've done that before, so I knew that existed. Fair. But we also have something cooler, which is the third thing. I'm not sure if this is included in substring, but this is every second character. Or even
Okay, in Java you can't do it that easily.
yeah,
Hooray.
we take every -1th character. So basically we start at the end and then we just go through the second, and then we can do every -2 character, which is starts at the end and then we skip every character. It's string slicing is really powerful. Or this works with any list, by the way. So I can say A is 1 2 3 4 5, and I can say A 2, and it will give 1 3 5. A -2, it will give 5 3 1. A 1 2 -1, and every second will give 2 to 4 because the list will be 2 3 4, and it will take every second one. It's a bunch of cool stuff you can do with this. Let's see, what else is there to say about strings? We have had the length. Another quick thing. I don't think I've mentioned this operator yet, but we have the modulo one. So we have 10 modulo 5, which is 0, which is just the remainder of a division. So we have the integer part of a division and the remainder part of a division using the double dash and the modulo sign. Alright, so I think that's everything about strings. Dictionaries. So dictionaries are what I guess in Java you would use a hash map for, or just normal, or basically a map. So a dictionary could be my dict is equal to Jurre is 19. Oh, Jelle is 19. I don't know. Let's keep it here. Or let's actually make Jelle a year younger, or 2 years younger, so you can see the difference. So now we have my dict, and it will be a dictionary which maps Jurre to 19 and Jelle to 17. So I can call it like this, my dict Jurre, and it will be 19. So this is just like a lookup table. Let's call it like that. And you can also do for x in my dict, print x, and that will print all the keys. And you can go one step further and print x plus a comma plus the string of my dict x, and try to figure for yourself out what this will do. I'll give you about like 10 seconds for that. Shouldn't be too hard. You guys mostly passed ADS, so I believe in you. So again, x will be the indexes, the indices for the, or actually they're called the keys for the dictionary. And then my dict x will be the values. So this will be Jelle 19, Jelle 17. And of course, as these are like dynamically typed, they can be anything, whatever you want. I can make this a list. I can make this a string. I can make this, I don't know, another dictionary. It's all allowed. As we say it in Dutch, je kan te gek niet doen. And it works.
Imagine if you were like looked out into like an actual dictionary and were like, for this word, please look into this other dictionary.
Oh god. And if you can fuck with memory addresses, you can also make them point to each other. Oh no.
Oh no.
Alright, so let's see, is there anything oh wait, are there a few things more I want to say? So you can do my dict.keys, which will give you a list of dictionary keys, and you can index this like anything. Oh, excuse me. You can convert this to a list and then index it like you would expect it to. And you can do the same with my dict.values. Oh, my typing is scuffed, man. Okay, that did not do what I expected it. Oh wait, actually it did, because this is another dictionary. I bamboozled myself. Haha. So yeah. Okay, that's dictionaries, and now we can look at modules. So Python has a huge library of amazing modules. There is a thing called pip, and with pip you can easily install modules. So you can say pip install request, for example. Actually, I think request is automatically bundled, but pip install PyCrypto or whatever, and then the module will be installed for you. No hassle having to download them manually or whatever. And the way you work with them is, for example, I'm going to work with the request module. So I can say import requests. Take a while, and there we go. And then I can say requests.get https google.com.text. And here, as you can see, another great feature of Python. When you have a long text, it will actually squeeze in lines for you. But this is what the source code is of the of a Google website. And because because I didn't call print on it, this is just the string itself. So it doesn't really display new lines very well. It will just show the new line character instead. And when you actually want to have the text neatly formatted, you can do print. And then it will actually work with new lines. So then, yeah, this is how it would look. Okay. Let's work with another library real quick called random. And we're going to do a little example. And because this is partially for the course PTS, I'm just going to do a little probability theory example. So I can say import random. And I can say for x in range 0 to 100. So again, this will just execute whatever's in here 100 times. I can say print random.randrange 0, 2. And again, it's included with the first one, excluded for the second one. And what this will do is this will print 100 random numbers between 0 and 1 included. So it will be either 0 or 1. And that's exactly what we expected it to. What we now can do is we can say...
I thought there was PST. You know, I thought there was I thought there was PTS, not computer organization.
What do you mean?
Because binary code. Because we did a lot of binary.
Okay.
Video.
Haha. Actually, if we wanted to look like binary
If
code,
I didn't fuck up the delivery, that would have probably been a bit better.
Yeah. But if we want it to look like binary code, we can actually say end is equal to nothing, and then it will all be printed on one line. But now let's do some probability theory and see. Okay, if we have a let's say 1s is equal to 0 and 0s is equal to 0. So we have our coin flip is equal to random.randrange. If coin flip is equal to 0, very important, do equal signs for comparison. And then we can say zeros. This is one of the bad sides of Python. There is no plus plus, you actually have to use plus is 1. And it's actually just saying zeros equals zeros plus 1. Or if you want to do it chaotic evil, you can do 0 minus is minus 1. Which subtracts minus 1, which adds 1. But I'm just going to do plus is 1. Else if coin flip is equal to 1, 1 plus is 1. So
You also
Oh,
do
don't
like,
put double. Double. Yeah.
thank you. So I can say ones, 61 ones, zeros, 39 zeros. So we got a little unlucky. And as you can see, if we have a not too big sample size of only 100, it sometimes tends to deviate a little bit. Let me actually put a...
and
Could you also say like 0 is plus plus instead of plus equals 1?
Nope. So plus
Okay.
plus, unfortunately, is not a thing in Python.
Okay.
Yeah,
That's
that's one
good
of the
to know.
sad things.
Yeah, I really love plus plus like in loops. So
It's
that's
so
kind of
simple.
Yeah,
takes some
yeah,
getting used to.
yeah. It will take a bit of getting used to, but there are some more things in Python that will take a bit of you getting used to, like not placing
Yeah.
semicolons. Or actually, semicolons
Yeah, that's
aren't
true.
disallowed, but they just don't matter. If you want, you can put semicolons everywhere. It doesn't matter at all.
Huh.
But yeah, string zeros, print ones plus string ones. And you can also use string formatting here, which would be a little neater, but ICBA. So yeah, here we can do this a few times. And as you can see, if we for example only take 10 coins, there will be a relative big amount of deviation. So like this is already like 20% difference. Like here,
Ooh.
this if you only saw this data set, you would not think this is a fair coin. However, if we crank this up to 1,000, we can see that it's already starting to be a lot less biased. And of course, there can still be outliers. However, most of like when you look at it in percentages, they will probably stay the same. I'm not exactly sure, but when you look at the absolutes, other way around. But yeah, the more numbers you add, the more likely it is to stay. Oh, that took a little long. But the more likely it is to stay to 50-50. And also, for right now, we're still using a coin flip between 0 and 1. We can actually make a dictionary called outcomes. Is equal to the empty dictionary. And make this something between 0 and 9. And to make it a little neater, I'm going to add 1, which will make it between 1 and 10. And then we can say if outcomes let's say call this result instead of coin flip because it's no longer coin flip. If outcomes result let's see, how would we do this? If it is already an integer, then we can just say, okay, this plus 1. Oh. Else, this is equal to 1. Are they by default? Ah, cool. Actually, this is actually a really shitty way to write my code, so I'm going to do it differently. I'm first going to do a for loop for x in range 1 to 11, which will be 1 to 10. Then we can say outcomes x is equal to 0. There we go. So what this does is at first it will set outcomes up to be a dictionary of the numbers 1 to 10, which will all have a 0 map to it. So as we can see here, it first all has zeros, and then we can see here it has the different values that we get from all the rolls. And this is not very neatly formatted, so I'm going to use the thing again for key in outcomes. Print key plus comma plus. Actually, I should use string here because this is an integer. Plus string outcomes key. Oh, one closing bracket too little. And here you can see the different results that get pulled, and they will all be relatively close to 100 because that's the way it's pulled here. This is just an equal chance of rolling out every number between 0 and 10. All right. I think that should be most of it. Yeah, realistically, I think this is all you will need on your way to do some Python magic for our courses. Are there any questions?
Do you think we'll need an actual IDE like PyCharm, or is this enough?
I'm going to be honest. I've coded in Python for the past 9 years now, and I don't think I have ever installed an IDE for it. You can. It will make your life easier. It's just that I've never gotten around to it. It adds a few nice little features like maybe like finishing your words and checking stuff as you write it. But yeah, for me, I just use this and it's good enough. Or in Linux, I use like VI and then just run it manually. But yeah, you can install PyCharm if you want. So if you want to install an IDE, the IDE of choice is usually PyCharm. Are there any other questions? Oh, there is one more thing I can say, and you probably won't use this in your things, but it is nice to know about Python nonetheless. The way you store stuff in, or the way you get user input is just the input function. So here I say x is equal to input, and that means x is just equal to whatever I enter. So there is no like read until, there's no blah blah blah. This is just input.
No scanners.
Yeah, it's like for Python, it is really if you want to prototype something quickly and it should just work, Python is your language. No bullshitting with dependencies, no nothing. It's just write some code, almost like pseudocode, run it, it works. So I can say something like this, and it will input it as a question, and now x will be your. All right. So that is everything I've wanted to talk about. I'm going to end the video here. If you have any questions, you can leave a comment or hit me up on Discord. The Discord will be in the description. And good luck on your studies.